Yeah. For the derived quantities that are said to depend on fundamental quantities for their existence, we have examples such as area, area, area. We have various types of shapes ranging from rectangle, square, circle, triangle, etc., etc. We can easily get the areas of these respective shapes. Looking at the first one, which is rectangle. Rectangle is known for its position of length and breadth. And to calculate the area, it's simply length times breadth. Now, for square, square is known to have length all through. So to get the area of square is going to be length times length. Circle, the area of a circle, fine. You should remember from mathematics that we have radius from here to here. Then here through this side is known as diameter. Diameter is 2 times the radius. But radius, on the other hand, is half the diameter. Don't forget that. Those are minor principles from geometry and mathematics. So now, to get the area of a circle, it's simply pi r squared. Pi times radius squared. That's the area. That's how you can derive the area of a circle. Now, for triangle, the area can be obtained from this formula: half base times height. Half base times height. Let me use the normal symbol. I don't want to use those. Half base times height. Now, if we try to break all these to their dimensional form, you find out that they are all having the same dimension, the same units as well. So length is measured in meter. Likewise, breadth measured in meter. Meter times meter will give us what? Meter square. Likewise, length times length will give us meter square, as you can see. Now, pi is a constant, a mathematical constant. Like I treated in my previous video, symbols used in physics. You know, pi itself is a Greek alphabet. So, and it's a constant. For the fact that it's a constant, it has to be treated as such. So in dimensional analysis, what do? We truncate, we eliminate, we expunge it completely. We don't make do of it. So we are going to work based on the radius. Radius is measured in meters. Then just put meter there. What do we have at the top here? Square. So meter square as well. Then the same thing we did to pi. You know, pi is 22 over 7. Sorry, beg your pardon. 22 over 7, which is 3.142. The fractional form is 22 over 7, while the decimal is 3.142. The same way we can treat this half. You know, this is the fractional form, which is 1 over 2. Decimal form is going to be 0.5. So we remove this during dimensional analysis. We're left with base. Base is measured in meter. Likewise, height measured in meter. Meter times meter will give us what? Meter square. So we can just pick any of these four to represent here as the derivation. So it's best for us to take that of a rectangle, which is length times breadth, which should give me meter times meter to give me my final result of meter square. Now, meter is traced to the fundamental quantity, length. So we can have it as the meter square here as well. Meter occurring, length occurring twice. You know, length, breadth, they are both representation of lengths. Hope you understand. So we have it as meter occurring twice. Meter square, that is product of two lengths to give us meter square. Now, the unit still remains meter square. We can move to the next, which is volume. Volume. You should be used to this our regular North seasoning. We call it Maggi in this part of the world, Nigeria. Maggi no. As Yoruba people, we have it. It's usually in cuboid form like this, cuboid form. So this is the length, this is the breadth, and this is the height. So in order for us to get the volume, we can calculate the volume with this formula: length times breadth times height. Length is measured in meter, of course. Breadth is measured in meter, likewise height. So if you multiply these three, you have meter cube. which gives us a perfect derivation of volume. So we can say the volume is calculated using length times breadth times height. That is volume of a cube, but don't get it twisted. Volume of other shapes will be different. I use this basic one to get just to derive what the unit of volume should look like, which will be in meter cube as derived earlier. So the fundamental equivalent, since everything is still in the fundamental form, length, because breadth represents length, likewise height represents length as well. So it's going to be in meter cube. This also in meter cube. Now, speed. It is measured, the formula for calculating speed is distance all over time. The formula for calculating speed is distance over time. Distance is measured in meters. Time, on the other hand, is measured in seconds. So we can have it to be meter per seconds. The unit is also meter per seconds. The same thing goes with velocity. The only difference between speed and velocity is that speed is a scalar quantity. That is, it has only magnitude but no direction, whereas velocity has both magnitude and direction. Velocity is calculated using the formula displacement over time, whereas speed is calculated using the formula distance all over time. Let's move to the next. Yeah, the next is acceleration. Acceleration. The formula to derive acceleration, or the formula to get acceleration, is simply velocity all over time. Velocity all over time. As you can see from here, velocity is measured in meter per second. So it is best for me to just put the meter per second here all over. Our time, which is a fundamental quantity, is measured in seconds. According to indices, what we have here at the denominator can be represented as 1 all over s, which is s raised to the power of minus 1. So if we bring this up, this is what I'm saying. We have meter per seconds divided by seconds. It means meter per seconds per seconds. So now, which is like product of these two, as you can see. So now it is meter s raised to the power of minus 1 plus into brackets minus 1, because for us to multiply these two, it connotes addition of the power according to indices. I'm not here to teach mathematics. It's under indices. You can as well cover that. So plus times minus, we know, is minus. Minus times plus is minus. Plus times plus is plus, while minus times minus is plus as well. This could be written as ms raised to the power of minus 1 minus 1. So minus 1 will eventually give us ms raised to the power of minus 2. That is why the unit for acceleration is in meter per second square, which is also in its fundamental form. Next is force. Force is defined as a product of mass and acceleration. Mass and acceleration. Mass, being a fundamental quantity, is measured in kg, and acceleration from above here is measured in meter per second square. So joining them together, we have the fundamental equivalent to be in kilogram meter per second square. That is kilogram for mass, meter for length, seconds for time. That is why we call it fundamental equivalent, showing you that combination of two or more fundamental quantities will give us what? The derived quantities. Now, the universally accepted unit for force is Newton. Newton, telling you that 1 Newton is equal to kg meter per second square. They are the same. So that's about that. Another one is pressure. Pressure can be calculated using the formula force all over area. Force. We all know from what we did previously that force is measured in kg meter per second squared. That is mass times acceleration all over area, which is having the units in meter squared. So what will happen here? The meter at the numerator, we cancel 1 at the denominator. So if you want to express this further, you can have it as kilogram per meter per second squared. So all these are the fundamental equivalents, kilogram per meter per second squared. Then universally, the units for this is in Pascal. Move to the next. Work. Work can be calculated using the formula force times distance. Force times distance. Of course, force is measured in kilogram meter per second square times distance is measured in meter. So at the long run, if you multiply this meter times this, you have kilogram meter square per second square. Kilogram meter square per second square being the fundamental equivalent. Then the unit for work is joule, joule J. Work, joule J. That's the unit. Energy, they say, is the ability to do work. The unit for energy is also in joule, which is connoted by the symbol J. Now the next one is power. 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 Power is calculated using the formula work done. Work done all over time taken. Time taken. Work done all over time taken. Work done from what we have here is measured in kilogram meter square per second square divided by time taken, which is in seconds. So when this one comes up, we'll be having kg meter square second raised to the power of -3. And the universally accepted units for power is watts, W. Watts, W. So if you've not subscribed to this channel, kindly click on the subscribe button, subscribe to this channel, then switch on the notification bell as well, so that when we post subsequent videos, you can follow up with us. Then if you've enjoyed this video, you've gained one thing or the other, kindly like the video as well. The next one is momentum. Momentum is having the formula mass times velocity. Mass times velocity. The mass, of course, is a fundamental quantity, which is measured in kilogram. The velocity is measured, of course, in meter per second. Combining both together, we have kilogram meter per second, which can also be represented with the unit Newton seconds. Do you know that you can break this down easily to get back this? Let's do it together. Newton is the unit for force, which is kilogram meter per second square. That is mass times acceleration multiplied by these seconds. Combining both together based on the principle of indices, you have it as kilogram meter s raised to the power of -1, which is still the same as this. As simple as that. More examples include impulse. Impulse, which is the product of force times time. And it is measured in, force is measured in kilogram meter per second square times time, which is measured in seconds. Combining this, we're going to be having kilogram meter second raised to the power of -1. So the fundamental equivalence will be kilogram meter per seconds, which can still be written as, from the derivation, is a product of force times time. Force is measured in Newton. Likewise, the time measured in seconds. You can see the unit for both momentum and impulse are the same. They are the same. Now let's see density. Density can be calculated using the formula mass all over volume. Mass, of course, is a fundamental quantity and it is measured in kg, whereas volume is measured in meter cube. Combining these together, we have kilogram per meter cube, which is also the known unit for density. Unit for density. So it's convenient for me to just stop my examples here and give you the rest as an exercise. So you go and you follow these formats that I've used the table to create yours. The exercise or exercises, because it's going to be much, include this. I want you to do the same for upthrusts. You can see the way I've been deriving it. I'll place the fundamental equivalent and unit. You do that for upthrust. You do that for magnetic flux density. You do that for torque. That is force times perpendicular distance. I'm giving you a clue anyway. You do the same for potential difference. Potential difference V. Then lastly, you do for resistance of a resistor. So you can do this and drop on the comment section, possibly. All right. We are going to be considering units in the main now. Units can be divided into three systems. Three systems. That is, it exists in three different systems. Namely, number one, we have the MKS system. MKS system, which uses the meter, kilogram, which is in kg, and seconds. Meter, kilogram, second. That's what MKS stands for. Number two, we have the CGS. The CGS system. This uses the centimeter, the cm, gram, G, small letter G, and seconds, second, S. The third one is the FPS. FPS system, which adopts the foot, pounds, normally, we can just say P, but in real sense, it is LB that connotes pounds. Foot is connoted by the symbol FT. Pounds is being connoted by the symbol LB. Take note. But for this study, for this particular system, I just represent them as F and P. Then we have seconds. Of course, the unit for second is S. So that's how we have the MKS system, CGS system, FPS system. You see, CGS system and FPS system are collectively called the Gaussian system. Gaussian system. Both CGS and FPS are called the Gaussian system, whereas the third one, which is the FPS, is otherwise known as the British engineering system. This one is otherwise known as the what? British engineering system. So that's that about that. You see the first one, which is the MKS. It is from here that they created the extension of the modern international unit system known as the SI unit, which we call System International the Units, SI units. It is from here that they got the SI units. So please take note of this.